Okay, so this is problem number 4, quadrilateral proofs, level 1. So we're given that E is a midpoint of AD, and that ABCD is a rectangle, excuse me. So we're going to say that AB is congruent to CD because opposite sides of a rectangle are congruent. So that's the first thing I did, because we are wanting to prove that ABE is congruent to DCE. So these two smaller triangles here. So we've got sides that are congruent. We can also talk about this being a midpoint, right? So AE is congruent to DE because I didn't select the right answer. A midpoint divides a segment into two congruent segments. Okay, so we've got two sides. And if this is a rectangle, what do we know about each of the angles of a rectangle? Well, they are 90 degrees. So let's talk about angles being a right angle, okay? So angle BAE is a right triangle because interior angles are right angles of a rectangle, right? So let's talk about CDE. So we have angle CDE is a right angle. Same reason, interior angles of a rectangle are right angles. Okay, but we still need to say that those are right angles are congruent. So let's say that angle BAE is congruent to angle CDE. And all right angles are congruent would be your reason, right? Okay, so we have side angle side. Now we can prove that these two triangles are congruent, right? So let's look at ABE. Let's make sure I type it in correctly. DCE is congruent because of side angle side. Okay, let's submit that. That was number 4. Good job. Okay, so this is number 5 that we will do together. We are given that AD and BC are congruent, so these two parts, and that A, B, and CD are congruent. So we have opposite sides of this shape that are congruent, and we have that CE is congruent to BE. So this forms like it bisects that, okay? So if we have opposite sides that are congruent, two sets of them, can we say that we can classify A, B, C, D as a parallelogram, right? A, B, C, D is a parallelogram because it is a quadrilateral with two pairs of opposite sides that are congruent. Okay, so we've stated that's a parallelogram. We are looking to prove that FBE, and DCE are congruent. So if this is a parallelogram, we probably need to say that these two lines are parallel. So DC is parallel to AB. Okay? Okay, so that's parallelogram. So opposite sides of parallelograms are parallel. There we go. Okay, so let's look at these angles, DCE and FBE. Because this is a transversal, those are alternate interior angles. They should be congruent. So let's talk about those two angles being congruent. DCE is congruent to DCE, FBE. Okay, parallel lines, where are you? Okay. Not corresponding, that's the wrong one. Okay, there we go. Okay, so we have a side and an angle. We also have a vertical angles here. So vertical angles are congruent. Let's talk about those two. So we can have angle, side, angle. right? Angle, side angle. Okay, so angles D, E, C are congruent to F, E, B, right? Because vertical angles are congruent. So now we have angle, side, angle. So we can state that those two triangles are congruent. So we can say FBE is congruent to DCE. Because of angle, side, angle. That is our proof. Hit submit. Good job. Okay, so that was number 5. Let's work on the last one together, number 6. Let's look at it. So we have a big parallelogram, A, B, C, D. We know that the angle GEC is congruent to HFA, and we know that AE, where are you, AE? Okay, is congruent to FC. So we want to look at GEC. So GEC and prove that it's congruent to HFA. Okay. So I think what I would like to talk about first, what could we do? This one's pretty tricky. Since it's a parallelogram, this is a diagonal. A diagonal is going to bisect both of these angles. So let's talk about that, right? Because, well, you could use the angle bisector, or you could say BC and AD are parallel, and then use alternate interior angles. So either way you could go about it. So I'm going to just use the parallel thing. So BC is parallel to AD, because this is a parallelogram. Opposite sides of a parallelogram are parallel. So if we have that, then we can say this is a transversal, alternate interior angles are congruent. So we can talk about those two angles. I'm going to label that GCE and HAF. Parallel lines cut by transversal, alternate interior angles are congruent. Okay, so we have two angles. We need to get a side. So this will be a little bit trickier. So I am first going to talk about EF. So EF is congruent to itself. It's not an angle. Let me select the right thing. It's a line segment. EF is congruent to EF. Reflexive property. So we can talk about this side, these two sides being congruent added to a congruent side will give you a congruent side. So we're going to talk about AF and CE being congruent, those line segments. So AF, CE. This is where we have to find the right thing. So segments added to congruent segments form congruent segments. Okay, so now we should have angle, side, angle. Angle, side, angle. So we can prove that these triangles are congruent. GEC and HFA are congruent because of angle, side, angle. Submit answer. Yes, I'm sure it's correct. There's probably another way to get that same answer using this. Like I said, you could talk about angle bisectors, but this is a good way to get this answer. So let's go back. We have one more to do. No? Did we do the last one together? Okay, so that's all of them that we did together. Use this, watch these videos. You have 3 to practice on your own today. Ask me any questions. I will try my best to help you with these 3.